We can navigate without any GPS because animals are able to travel in the world without any connection to this kind of networks. I'm Julien Serre, a senior lecturer at Aix-Marseille University. We can find desert ants in North Africa and at the same latitude all over the world. And these animals is able to navigate in a desert, which is an arid zone without any contrast on the ground. And 60 years ago, Professor Rüdiger Wiener from the University of Zurich in Switzerland has spent all his life to study these little animals in Tunisia. And he found out that this animal can accurately navigate in the desert by making a journey of about 1 kilometer, and then he is able to come back in a standalone way to this nest. So it's an amazing behavior, and that's we are trying to rebuild in our research lab. The hexapod AntBot imitates the optical path integrator inside the Cataglyphis brain, which is based on two sensory modalities. So the first one is the detection of an optical heading, and the second one is the estimation of the travel distance. So to measure the travel distance, the desert ants measures the optic flow velocity coming from the ground. There is a little sensors in front of the robot looking toward the ground, and while the robot is walking, this optical sensor is able to detect the optical velocity coming from the ground. By integrating this information, we can measure the travel distance. So there is another way to estimate the distance. It is a steps counter process. We can use the servomotor signals generating by the locomotion in order to count the steps. The desert ant is also able to estimate the distance by a step counting process. So by combining this information, we can estimate the travel distance accurately, and then the other information is the detection of the heading. So there is a little evidence that insects are sensitive to the magnetic field. So they are not able to use these informations like human navigators in order to find their heading. So they use the skylight, and this natural light is polarized by the atmosphere. So there is an interaction between the sunlight and the atmosphere, and it generates a polarization pattern. So humans are not sensitive to the polarized light. However, insects or birds or fish are sensitive to this light in order to find a special cue in the sky in order to find their heading. So they use this visual information in order to compute their heading, and then at any time the ant know what we call the homing vector. So at any time from this nest, he is able to know the distance and the orientation to reach directly the nest by moving straight forward. I carry out some experiments in insects as well. So for instance, I'm interested in understanding how honeybees can control their altitude in order to implement autonomous altitude control system on board flying drones. I'm also interested in how ants can navigate in space and detect their heading visually. So we are trying to find technological solutions which could be adapted to the autonomous vehicles or autonomous logistic droid. So the constraints in terms of measurement frequency and heading accuracy is different in function of the scale of the robot. I'm also interested in hands behaviors in order to develop an artificial celestial compass, which is an alternative to the magnetic compass, and also route followings in hands in order to be able to navigate in downtown, for instance, without any maps. And currently we are working with industrial partners in order to get patents.